I welcome you to our mathematics class today. This is Shedrack Kimale Secondary School and this is Form 2 Mathematics, topic similarity and enlargement. Similarity and enlargement. So we are looking at the volume, scale factor and the surface area. So let's take a question and see how we can find the surface area of a given question where we are supposed to find the volume of two similar solids that are given different lengths. You might refer to the previous videos where we talk about how to find the volume, scale factor, area scale factor and the linear scale factor. And we said that to get the volume scale factor, you cube the linear scale factor. And to find the area scale factor, we square the linear scale factor and so on. So let's take a question and see how that goes. So here is the question that we are given, that the volume of two similar solids are 800 centimeter cubic and 2700 centimeter cubic. If the surface area of the larger one is 21, that is 2160 centimeters squared, find the surface area of the smaller one. So how are we going to handle this? Of course, we are required, what we are supposed to do here is first of all to find the volume scale factor. To find the volume scale factor, we are required to identify the ratio of the volumes. But note that we obtain the linear ratio by finding the square root of the area ratio. And it is also important to note that we have to simplify the ratio or the area ratio to its simplest terms before finding the square root to avoid tedious calculations. Because if you don't simplify your given answers, you might get answers that are tedious. And we avoid that by simple simplifications. So let's go ahead and solve the given question. You can take this up a bit and then we see how to answer this question. So the first thing that we need to do here, we are looking for the solution. So our solution in this case, we can clean up this so that we want to answer this question. Solution. So we want to start by looking at the volume scale factor, and I have said the volume scale factor is nothing but we are required to identify the ratio of the volumes. So this means that we are given, if you look at the question, here you see the volume of the two solid are 800 and 2700. So what happens here is that we have 800 divided by the smaller one, which is 2700. You can as well decide to do 2700 divided by 800, but whatever you do, ensure that you are consistent. So if we divide this, of course, if you look at this, this can actually cancel each other, so that what we are having now will be 8 over 27, 8 over 27, which is the area. But remember that we are asked, or we were asked to if the surface area of the larger one. If you look at the question, you can see that it is indicated that if the surface area of the larger one is 2160 centimeters squared, that we need to find the surface area of the smaller one, the surface area of the smaller one. So this implies that what we need to do here is, because we cannot use the volume scale factor to find the surface area, so we need the area scale factor. So area scale factor, therefore area scale factor area scale factor in this case is nothing but the linear scale factor, squared. We square this. That's how we can find the area scale factor of this given question. So this implies that our linear scale factor is nothing but we said that the linear scale factor is going to be the cubic, because now this is what we are given. So a linear scale factor is the cube root of the volume scale factor. It is the cube root of the volume scale factor. So this implies that we are going to have cube root of 8 all over 27. 8 all over 27. And this will give us 2 over 3. So therefore our linear scale factor is nothing but 2 over 3. So now we can proceed to find the area scale factor, and we know that area scale factor, like we indicated above, is a linear scale factor squared. So it implies that our area scale factor is going to be given by 2 all over 3, but now we are going to cube this, we square this, so that we get 4 over 9. So this is what we have, 4 over 9. Now we can find the surface area of the smaller one, because whatever we have here is the area scale factor. If you go back to the given question, our target is to find the surface area of the smaller one, bearing in mind that the surface area of the larger one is 2160, that is 2160. So what we are going to have therefore is going to be 4 over 9 that we got as the area scale factor will be equal to now we don't know the area of the smaller one. This is 4, so we call that smaller one x divided by the bigger one that we are given in the question, which is 2160. So now you can go ahead and find our value for x. You can cross multiply, or here we can simply say that 4 divided by 9 multiply by 2160. This will give you, if you use your calculator, you will simply get 4 divided by 9 times 2160 will be 960. It is 960 centimeters squared, and this will be the area of the smaller one. Or if you cross multiply, you will have, if we multiply 4 by 2160, you will get 8640. That will be 8640, and this will be equal to we multiply 9 by x, that will be 9x. So that you divide both sides by 9, and 9 and 9 will cancel out, so that our x therefore is going to be the same, 960 centimeter squared. And this is what you are required to do when you are given any question that is related to the volume scale factor, and you have to find the surface area of the smaller one or the surface area of the bigger one. Hope you have understood. Let's see what you have to say in the comment sections.